Ever wondered how machine learning algorithms group similar objects or predict categories? Today we're diving into the intriguing world of clustering and classification algorithms, two fundamental pillars of machine learning and computer vision. Strap in and prepare to explore these two fascinating areas of artificial intelligence. First, let's talk about clustering algorithms. These are designed to group a set of objects in such a way that objects in the same group or cluster are more similar to each other than to those in other groups. It's a form of unsupervised learning where the algorithm discovers inherent groupings without using previously known or labeled outcomes. There are several common clustering algorithms. K-means, for instance, finds clusters by attempting to minimize the variance within each cluster. It's simple, fast, but requires specifying the number of clusters beforehand. On the other hand, dbScan forms clusters based on dense regions of points, which is great for data with irregular shapes and for outlier detection. Hierarchical clustering builds a tree of clusters by merging or splitting clusters based on distance metrics. In terms of computer vision, think of clustering as the process behind image segmentation, object recognition, and compression. For instance, in image segmentation, clustering can group pixels into segments based on color, intensity, or texture, aiding in the understanding of different objects within an image. Now, let's shift gears and discuss classification algorithms. These algorithms predict or classify the categories or labels of new observations based on a training dataset containing observations whose category membership is known. It is a form of supervised learning where the model learns from the labeled training data to make predictions. Common classification algorithms include decision trees, which model decisions and their possible consequences as a tree. Support vector machines find the hyperplane that best separates different classes in the feature space, and they're very effective in high-dimensional spaces. Random forests use multiple decision trees to improve classification, accuracy, and control overfitting. And then we have neural networks, which are capable of capturing complex relationships in data and are especially used in deep learning for computer vision tasks. In the realm of computer vision, classification is crucial for tasks like image recognition, where the algorithm classifies images into predefined categories, and object detection, where objects within images are identified and classified. So, how do clustering and classification compare? Well, they differ in their learning type, objective, data requirement, and complexity. Clustering is an unsupervised learning method, finding intrinsic groupings in the data without the need for labeled data. Classification, on the other hand, is a supervised learning method, predicting the correct class label for given inputs using a dataset with known labels. While basic clustering techniques like K-means are simpler and more straightforward, classification algorithms, especially advanced ones like neural networks, can be complex and harder to interpret. In conclusion, both clustering and classification play crucial roles in machine learning and computer vision, with distinct purposes, methodologies, and application areas. They provide the backbone for many of the AI technologies we use daily, helping machines to understand, interpret, and learn from the vast amounts of data they process.